So, in this new video, we're going to look at solving equations, but not the equations we've solved before. Not these linear equations. And we call them linear because if we were to graph these as y equals 2x and y equals this, they would be straight lines. But now we're going to look at quadratic equations. Well, first off, we need to define what a quadratic equation is. Well, this is a quadratic equation. This expression has a highest power of 2, and it's equal to something. Therefore, it's a quadratic equation. You can see here another expression that's equal to something that has a highest power of 2. Therefore, it's a quadratic equation. Now let's just clarify, if I put x cubed and stuff equals something, that's a cubic equation. Next up, if the highest power is 4, it's a quartic, and then it's a quintic, and so on. Now, you may solve these later on in certain situations. It's unlikely you'll solve many of these or any of these, apart from very basic ones, like x to the 5 equals 32, where x would be 2. We're going to focus on quadratic equations. Now, if you've been watching some of my previous videos, you will have seen part of the strategy we're going to talk about first, after we dispel one myth. So, if I said to you x squared equals 4, you can probably solve that equation. Now, things you need to be aware of. You're going to look silly if you just say x is 2. Now, I know a lot of you did, because everyone does. Because you think about numbers and you go, 2 times 2 makes 4. And it does. But what else times by itself also makes 4? That's right. Minus 2 times minus 2. Okay? And 2 times 2. They both make 4. So the answer is plus or minus 2. Easy to solve. Easy issue to avoid. So x squared equals 25. Yes, x equals plus or minus 5. X squared equals 100. Yep, x equals plus or minus 10. X squared equals 7. X equals plus or minus whatever the square root of 7 is. So the first thing to establish here, okay, is that a quadratic equation has 2 solutions. Does that make sense? Well, a linear one with a highest power of 1 had 1 solution. You might be thinking now, well, if a quadratic has 2, a cubic has 3, a quartic has 4, and a quintic has 5. And you'd be right. Now, sometimes those solutions aren't as simple or as obvious as it seems. Take, for example, this equation. Well, hang on. How does this have 2 solutions? Because x equals plus or minus 0, which is the same number twice. That's right. It is a repeated solution. So it can have the same solution twice of 0. You don't need the plus or minus. but it does have two solutions. It's just repeated. Okay, that's the principle of a quadratic equation. Now, let's look at a situation where we may have to solve one. Okay, here is a quadratic equation. Now, your first thought might be to use trial and error or trial and improvement. And that's a good idea, because trial and improvement will lead you to an answer eventually. But if the answer was x equals minus 2.735, you could be here for quite some time. So we don't want to use trial and improvement. That is not ideal. We want a precise method, because it will only really be useful maybe for integer solutions. Because if we guess 1, 2, 3, 4, minus 1, minus 2, we might hit on some solutions, and that's great. But not this. So, how can we solve this equation? Right. Well, let's solve a different equation first. Because actually, this one you know how to do. And you first solved this equation back probably in year 5 or 6 or maybe 7 or 8, depends on when you saw it. And let me say it to you in words to help you. So, I've got two numbers multiplied together. When I multiply them together, the answer is 0. What can you tell me about those numbers? Well, you can probably tell me that one of them should be 0. So either A is 0 or B is 0. And you might say, or A and B are both 0. Now all of this together is wrong. But most of it's right. A and B are different letters, which means they're different variables. If they had the same answer, you wouldn't use two different letters. So they can't both be 0. So, either this one is 0 or this one is 0. I can hear what you're saying now. Looking at this expression you've given us, it doesn't make any sense. How are we supposed to know? How could we, rather than having 3 terms added, have an expression like this? Well, let me show you an example. If I had x multiplied by x minus 2, I've got two expressions. A simple one, just x, and then another one, x minus 2. This is A times by B. Okay. Now it could have been written as x squared minus 2x, but it wasn't. It was written in this form, which is factorised. And hopefully now you can see where this is going. Now, if you haven't watched the videos on expanding and factorising brackets, you need to go back and do that now before you go any further. Here, you would have x is 0, or you'd have x minus 2 is 0, following our rule from here. Now, so x is 0, or x is equal to what? That's right, 2. So there we have two solutions. Two things multiplied together equal to 0 allows me to identify two solutions. So let's just check for this one up here. Let's come down here and factorise this. So, knowing that it just says x squared at the start is really helpful. So the two numbers just multiply to make this. So it's x, and then a pair that multiply to make 6 and add to make 5. So my pairs are 1 and 6 or 2 and 3. Aha! 2 and 3. So either this is 0 or this is 0. Now the first one gives you minus 2, which if you look at the bracket now, you might even see that. The second one gives you minus 3. And again, Okay. The factorising can get more complicated than this. If you had this in brackets, you'd say, so I've already factorised it, how do I solve it? You'd say this bracket is 0 or this bracket is 0. And then you'd solve both of these equations. So 2x is 5 and x is 5 over 2. No need to simplify. Here you'd get 3x equals 11, so x is 11 over 3. Not quite as easy to see from the brackets. Now, I'm going to highlight this 0 and say it's really important. And here's why. Let's do pairs of numbers at times to make something else. Let's say 4. That's 1 times 4 and 2 times 2 come to mind. It can't be that, but it can be a half times 8, a third times 12, a quarter times 16, a fifth times 20, 1 over root 3 times 4 lots of root 3, 0.27 times 4 over 0.27. I can write them all day. There isn't one pair of values. I could write infinitely many solutions. I only get one pair when it's equal to 0. So let's quickly recap. We know what a quadratic equation is because the highest power is x squared. We know that we have to watch out for x squared equals 4 giving us plus or minus. And we saw that in several other cases because a negative times a negative also makes the same number. We're expecting two solutions, even if one is repeated. Then we looked at, because if it's equal to 0, two things times together, one of them must be 0. So if we can take a quadratic expression and factorise it, we can get the two solutions. And it only works equal to 0 because of all the other pairs you get if it's not. So method 1 for solving equations. Equal to 0, factorise, solve. Practice this now and then we'll get looking at some other methods. Yet if you need to practice factorising, go back to the video on factorising.